In this lecture, we're going to talk about section 9.2, which talks about sum and difference identities. So we have sum and difference identities for both sine and cosine. But first, what we're going to look at is the sum and difference identities for cosine. So basically, we have for the sum formula, if you have cosine of two angles, alpha and beta, so cosine of alpha plus beta, that's going to be equal to cosine alpha times cosine beta minus sine alpha sine beta. So in this case, alpha is your first angle, beta is your second angle. Similarly, if we want to find the difference of two angles, alpha being the first and beta being the second, well, cosine of alpha minus beta is going to be cosine alpha times cosine beta plus sine alpha times sine beta. Now let's look at some examples where we may use this formula. So for instance, let's say we're asked to find the exact value of 5 pi over 4 minus pi over 6. Well, the first thing I always do is write my formula. So we know that it's a difference formula, so it's going to be cosine alpha minus beta. That's going to be equal to cosine alpha cosine beta plus sine alpha sine beta. So in this instance, my alpha is going to be 5 pi over 4, and my beta is going to be pi over 6. So I'm just going to plug in. So this becomes cosine 5 pi over 4 times cosine pi over 6 plus sine 5 pi over 4 times sine pi over 6. Okay, so now basically, hopefully you guys kind of already have a little bit of a familiarity with the unit circle, but basically we're looking for the value when cosine is 5 pi over 4. And so we know that's going to be in our third quadrant, right? And cosine of 5 pi over 4 is negative root 2 over 2. Cosine of pi over 6, that's going to be root 3 over 2. And so I'm looking here. Plus, now sine of 5 pi over 4 is negative root 2 over 2. And sine of pi over 6 is 1/2. And so now what we're going to do is just simplify. Okay, so if you multiply two things under a square root, the square root stays and you multiply what's underneath. So this is going to be a negative, since it's negative times positive, so this is going to be root 6, and 2 times 2 is 4. This is also going to be a negative root 2 over 4. And if we were to combine them, now we cannot add and subtract radicals, so they'll have to stay. So it will be negative root 6 minus root 2 all over 4. And this is your answer. Okay. Let's look at another example. So if we recall the unit circle, so let me copy and paste it really quickly. If we recall the unit circle, note that 75 degrees is not on the unit circle, right? And we've only done examples where we are looking at values on the unit circle. So how can we come up with a value for this? Well, we can utilize the sum and difference formula. Now, we are all different, so we may think differently, right? So basically what we're going to do is come up with two angles that are on the unit circle that I can take the sum of the two angles to get 75 degrees, or I can take the difference to get 75 degrees, right? So You could do what, 90? Nope, there's no 15. So really what we could do is, let's see, 45 plus 30 would give us 75, and you can play around it. But like I said, we all think differently. So we may come up with different ideas. But the quite obvious one is we can split this as, so I'm going to write cosine 75 degrees. We can split this as cosine 45 degrees plus 30 degrees, right? Because if I add those, I'll get 75. But now what I'll do is utilize my sum formula for cosine. So I know that cosine of alpha plus beta, well, that's going to be equal to cosine alpha cosine beta minus sine alpha sine beta. And so I'm plugging in, of course, this is my first angle and this is my second angle. So this becomes cosine of 45 degrees times cosine of 30 minus sine of 45 degrees times sine of 30, right? And so now we're just going to plug in. So cosine of 45 is going to be root 2 over 2, while cosine of 30 is root 3 over 2. Then sine of 45 is also root 2 over 2. And sine of 30 is 1/2. Like we did before, we're just going to simplify. So this becomes root 6 over 4 minus root 2 over 4. So this becomes root 6 minus root 2 over 4. And that's your answer. So no need to put in decimal form or anything of that nature. You can leave your answer as is. Now we're going to look at the sum and difference for sine. So if you have two angles, alpha and beta, you want to take the sum. So sine of alpha plus sine of beta is going to be sine of alpha cosine of beta plus cosine alpha sine beta. And then the difference formula, where we have sine of alpha minus beta, well, that's going to be equal to sine of alpha cosine beta minus cosine alpha sine beta. So let's look at some examples. And really all we're doing is like we did before, we're plugging in. If you need to break up your identity, your angles to get two angles on the unit circle to evaluate your angles, you can do that. But basically, we're going to be doing what we've been doing with cosine. So for instance, here we want to find sine of 45 degrees minus 30 degrees. So I'm going to, again, write my formula. So we know that's sine of alpha minus beta. Well, that's going to be equal to sine alpha cosine beta minus cosine alpha sine beta. Of course, this is my alpha and this is my beta. So I'm just plugging in. So this becomes sine of 45 degrees times cosine of 30 minus cosine of 45 degrees sine of 30. So we know that sine of 45 is going to be root 2 over 2. And cosine of 30 is going to be root 3 over 2. And so cosine of 45 is also root 2 over 2. And sine of 30 is 1/2. So we're just now simplifying. So this becomes root 6 over 4 minus root 2 over 4. And so this becomes root 6 minus root 2 all divided by 4. Okay, so really straightforward. Nothing really different when it comes to tan. Of course, we can derive these. It will take us quite a bit of time to derive them, and I found that students don't really care of the derivation of these formulas, so I'll just give you guys the formulas. All right, so for instance, let's say we have tan. Now, tan, remember, we know that tan of theta, just want to make sure we don't make this mistake. That does not mean that tan of alpha plus beta, I'll say plus or minus, is sine of alpha plus or minus beta over. This is not the case. So do not get this mixed up, guys. Just wanted to make this note. Okay, this is not the case. All right, so this is what the correct formula is. So if you have tan of alpha plus beta, that's going to be tan alpha plus tan beta divided by 1 plus tan alpha times tan beta. If we're looking at tan of the difference of two angles, well, that's going to be tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Well, let's utilize the formula and see how we can use it. And really, it's just like we've been doing with sine and cosine. So once you know the formulas, you should be able to evaluate whatever is being asked. So like before, we're going to note. So if we have tan of alpha plus beta, since it's a sum, we're going to do alpha plus beta. That's going to be equal to tan alpha plus tan beta divided by 1 minus the product of the two. Okay, so of course, this is my alpha, this is my beta. So I'm just going to be plugging in. So this becomes tan of pi over 6 plus tan of pi over 4 divided by 1 minus tan pi over 6 times tan pi over 4. Now, recall now that, put this in a big parentheses, tan of pi over 6. So to find tan of pi over 6, let's go here and copy this so we can kind of see. Okay, so to find tan of pi over 6, so remember, tan is sine over cosine. So this would be root 3 over 2, and I'm just doing this first one so you guys can see, divided by 1/2. But we know that this is going to be keep, change, flip. So this is going to be root 3 over 2 times 2 divided by 1. The 2's cancel, so this is really let me see. Oh, I did cosine. Oops. So this should be 1/2 sine over cosine. There we go. Divided by root 3 over 2. Okay. And so keep, change, flip. So it's going to be 1/2 times 2 divided by root 3. These cancel, so you'll have 1 over root 3. Okay, so I'm going to put that in place here for tan of pi over 6. So this is going to be 1 divided by root 3, and I'll simplify at the end. In a similar fashion, you'll see that this is going to be plus 1 tan of pi over 4. And then divided by 1 minus pi over 6. Tan of pi over 6 is 1 root 3 times 1. So what do we have? Well, we have 1 over root 3 plus 1 divided by 1 minus 1 over root 3. So we kind of have to simplify this a little bit more. So for my numerator, well, just like you would have to get the same LCD, I'm going to multiply this by root 3 over 3. And so this is going to become 1 plus root 3 over root 3. So that's going to be my numerator. One plus root 3. And in a similar fashion, my denominator is going to be root 3 minus 1 over root 3. Remember that this was in brackets, so we would have to simplify that. And so this is the same thing, 1 plus root 3. So really what I have is 1 minus 1 plus root 3 over 3. Okay, so if you were to simplify, you get the denominator. So let's kind of walk through it just to make sure. So this would be root 3, and put up here so we have space. Root 3 over root 3 minus 1 okay. So this is, actually no, this isn't plus, this is times. Oops, gotta be careful. So this is times 1. So this is just 1 minus root 3. 1 minus 1 over root 3. There we go. So this is just, and so that's how we will get root 3 minus 1 over root 3. There we go. Okay, so just some simple simplification. All right, so now at this point, let me kind of go up. I don't want to erase anything. All right, so now at this point, we're going to utilize our keep, change, flip, noting that our numerator is 1 plus root 3 over root 3. Keep that. Change to multiplication. This becomes root 3 divided by root 3 minus 1. My root 3's cancel, so I have 1 plus root 3 over root 3 minus 1. And this is my answer. So it gets a little bit messy, but once you keep your algebra together, you should be fine. Okay. All right, now sometimes you may be asked to use the sum and difference identities to verify identities, right? And we've seen that we've verified identities in the past. Okay, so let's see. We're asked to verify that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine of alpha cosine beta. All right, so what I'm going to do is first I'm going to write what these are. So sine of alpha plus beta, we've seen these before. Well, that's going to be equal to sine of alpha cosine beta plus cosine alpha sine beta. Okay, now sine alpha minus beta, well, that's going to be sine alpha cosine beta minus cosine alpha sine beta. Okay, so I'm going to plug these in and simplify. So we know that when you're verifying identities, you want to pick a side. Sometimes we say you pick the most complicated side and try to simplify it to be the other side. So in this case, I'm going to pick the left side. So I have sine of alpha plus beta plus sine of alpha minus beta. So I'm just going to plug in my formulas. So this becomes sine alpha cosine beta plus cosine alpha sine beta, and then plus sine alpha cosine beta minus cosine alpha sine beta. And now I'm simplifying. So we know that these will go because they're the same, and it's subtraction and addition. So you have 1 sine alpha cosine beta, and then you have another one here. So what does that give me? 2 of them. So this is 2 sine alpha cosine beta. And that's correct. So we've proven what we needed to prove. Okay, so we'll stop here for today, and we will pick up next time. Be sure to do your homework.